Hello. Boy, my throat's a little funny. Hello, everybody. This is David D. Hilster, and I've been working on a video forever. It's over 20 minutes long. Been busy, and I don't know. I just can't get through this one. It seems to be a little difficult, but it's actually a really great video. I'm going to keep working on it. But in the meantime, I'm using our new system here, which is called StreamYard. StreamYard allows us to stream live. We use this for our CNPS, Chappelle Natural Philosophy Society's Saturday morning chats. That's tomorrow morning at 10 a.m. So you can see that 10 a.m. for those interested in participating in chat about science in general. A lot of times they have people who come and present something. This is a live, just sort of chat on the Dissident Science channel. I appreciate all you subscribers who have been subscribing to me, and I do apologize, like I said, because I have not come out with a video for a little while, but I've been working on that, and I've needed somewhat of a break because I went for 2 years pretty strong into that. But today I'm going to be talking about some articles, and also hopefully some people will be joining us because if you want to join and talk to me, ask me questions live, you can, or you can make commentaries there. For instance, there's a person, Stefan, said hello, and hello, Stefan. So if you do want, you can participate in two ways. You can either send a comment directly to me, or you can, in fact, join live with me. You don't have to join necessarily with a video feed. You can just do it with audio. And you can go to live.dissidentscience.com, and that will bring you to our waiting room on StreamYard. And I will be able to put you up and on the air, and we can talk if you have any questions. But if you do have questions and you want to make any comments, you can comment in the area. We're right now going live to Dissident, my Dissident YouTube channel, and also our CMPS YouTube channel, which I'm one of the directors there. So anyways, let's go forward. As people are starting to join, I'm going to talk about some articles, some interesting articles that I always see these things in the news, and hopefully if I can do this every week, then we can talk about these. But a lot of these things actually I'm not really thrilled about to see, because when you read them, you get the impression that things are really wonderful and amazing, and things are going forward in cosmology and physics. But we're going to take a look at this article here. It's a new, and it just came out. It says numerical evidence for the merger of MOTS as MOTS inside a binary black hole. Now, this is sort of curious right away, because we don't have any idea what a black hole really is. What we have is space-time. We don't really know what that is. We call it a foam. We call it a fabric. We give it a physicality. It's not a physicality. But regardless, it is quite evident that we don't know about it. And one thing I do want to remind everybody is that 99.9% of physicists are not theoretical physicists. In fact, people who do study physics in the university, many of them who do take the physics courses and start studying theoretical physics, they get out of it real quick. And I've talked to numerous people in that vein, and what they say to me and have said is that it's just too crazy. It's lost. It's not something they want to do. It's sort of a house of cards built on another house of cards, built on another house of cards. And unfortunately, the very, very few are the ones that get all the publicity, because it's not necessarily, how do you say, interesting to the public in general to say, guess what? We don't know what light is. We don't know what gravity is. We don't know what magnetism is. We can describe all kinds of things. We can have discussions about how things may work. But the problem is that right now we are talking about a standard model, in cosmology and in physics that really has a lot of problems. And one of the problems is that we have people who have spent a lot of time looking at black holes and the Big Bang and particle physics and plate tectonics and the Standard Model, and have come to realize in a very short amount of time that we don't know what we're talking about. We don't know what's going on. To give you an example of that, it's our chief science officer for the CMPS. She has her PhD. Her name is Dr. Cynthia Whitney. She's got her PhD from MIT in physics, in theoretical physics, and she got it with special relativity. Now, you would think that a person like that, of course, will be a person that wouldn't end up in a group like ours, which actually challenges Einstein. So most of us know he's wrong. Well, let me tell you her story really quick. And of course, you can go to that story online as well. I'll get to that while I'm talking. If you go to sciencewoke.org, for those who don't know about that website, let me put that up. I see Stefan is there. Hey, Stefan, I do see you. If it looks like maybe you're interested in talking, but that would be really great. But anyways, I'm going to show this website here, and let me just move that. That's what I'll do. I'll go to here, and on this website, Science Woke, you can see the scientists, and one of the very first scientists are Cynthia Whitney. If you read her story, you can click on that. Let me click on that. Very interesting. She basically said, okay, you're a woman in the 1960s, you got your PhD from MIT in relativity, and you're ready to apply your work to the first practical application, a ring gyroscope. Only one big problem: relativity fails miserably at what is known as the Sagnac effect. You can read her Eureka story, and she goes on challenging. So that's a person that, in fact, is one of the people who take the time to look at physics, look at relativity. The problem is we read articles about it. We assume those articles are correct. We assume that everybody in the university is telling us something that must be true. And that when you actually take the time to look at it, relativity is very unique in the sense, I forget who said it, but I believe it was Dr. Glenn Borchert, a really great philosopher. He basically said, that it's the only theory out there that has, well, at least we know, almost 10,000 people, from physics professors to physicists to engineers to people who tried to work with relativity and it didn't work, coming to the same conclusions. So if it's the case that they are coming to the same conclusions, then maybe there's something wrong. And what I would urge you to do is to come to this website and find out yourself. We tell you how to become a critical thinker, and that's the idea. The idea is, don't listen to me about this stuff, read about it and make up your own mind. And many, many, many of us have done that, and that's what the Science Woke website's all about. It's very well organized. We get a lot of views on this, becoming Science Woke, learned what is wrong with big science. We have a lot of evidence about the problems. Get to know the people fighting big science. This happens to be Dr. James Maxlow, who is in my opinion, the best geologist that has ever lived. He has written the most important book in geology. I believe it's now available here in the United States. But anyways, and then of course, then read about new exciting models. We have one with Jeff Yee. My father and I have one. There are many people who are out there trying to come up with better models because the current model has no physicality. So, I see people are chatting here. That's what happens. Let's see, we got Matt Rico. This is actually so false. So we got some trolls here tonight. Didn't have them last time, but hopefully the guys will. If you're not interested, go. I mean, I think what's really amazing to me is how people relegate themselves so quickly to obscurity. What I mean by that is, if you don't take the time to look at the problems in physics, you're going to end up being part of the Flat Earth Society. So the people who are saying that I'm talking about a bunch of crazy stuff, of course, is those are people who do not look at our criticisms. They don't look at saying, oh, by the way, light doesn't bend outside the corona of the sun. It only bends through the corona, or through coronas of other suns, or through things in the universe. It's not space-time or gravity that's bending light. This is from a NASA scientist. No one seems to try to answer that question or go and actually see the measurements where that's true, or general relativity is supposed to be bending light. But anyways, it's something that is mind-boggling to me, how people do not look at things themselves. When someone comes up to me and says, oh, Einstein's wrong, or oh, this is another idea that I think is really happening, you have to be like Aristotle. In fact, I think I have here, memes, if you want to get some of our memes and use those. Yep, my favorite one right at the top, it says, it is a mark of an educated mind to be able to entertain a thought without accepting it. And that means, obviously, if you don't agree with it, that you can entertain that thought. But if you come out onto my YouTube channel, you come into these live sessions and you just come here and saying this is all baloney. I mean, that's, if you were in a debate class in whatever university, you would get a failing grade. Debate and talking is about talking about evidence. If someone gives you counter evidence, which we have a lot on this website, if you haven't been to it, on plate tectonics, black holes, relativity, quite a lot, the Big Bang, even math. I'm a mathematician. The current mathematics that we have has some problems. Quantum mechanics, the way stars are built, dark matter, which a lot of us who've looked at it believe that you don't need, and particle physics itself. So the thing is if there are problems in mainstream science and you refuse to look at them, then that is absolutely your problem, not anybody else's problem. So anyways, I see Justin, you're so Justin follows. So you're the only one who's ever understand it, and you don't think that you're crazy. Now, I don't know if these people, I do have trolls here, so also you can, good evening, Dave. Oh, there's somebody who actually thinks on their own and actually is a critical thinker. I mean, that's what I'm saying. These people jump onto here into the comment areas, and they just show right away they're not critical thinkers. They're just not. They can't do what even Aristotle said a couple thousand years ago. They can't entertain problems in science that we show are absolute problems in science. They don't entertain that. They don't look at it, and so that's cool. They are relegating themselves 100 years from now, when we know black holes, what we think are black holes are something else. Yes, they're dense objects. We know that now. Plate tectonics is really expansion tectonics. That relativity we really have to throw out. Quantum mechanics we have to really throw out. We have to fix our math system. Simple things like negative numbers, even when physics don't exist in the real world. The Big Bang, you can throw that out to eternal universe, stars. We got all those kinds of things. So, oh, I see, Justin, not you, Dave. I was responding to Matt. Okay, Justin, no problem. And Stefan, you are there. I wanted to say hello at all, or discuss something. I do see you lurking there. I did see you have a video. Did you want to say something in the chat there? And do exist in the real world. Well, anyways, just saying something without talking about it. Here, Matt. Matt, this is your problem. I'm doing a video exactly on this kind of thing. When you come in and someone says there are no negative numbers in the real world, you're going to say, "Oh, that's interesting. Tell me about it." That's an educated mind. It's not just saying, "Oh, there isn't." I mean, if you were in a debate class, you would be absolutely fail. They'd take you off stage because, "I'm sorry, you don't know how to debate. You don't know how to even have a discussion." Now, what's interesting is my father is the one who actually wrote an article about this. Let's see here. No negative numbers. Actually, this is started. He's got a lot done. So here's an article. if you want to go to sciencewoke.org. In fact, let me put that up there. I'm going to type in there. I don't think I have that there. I should have that as a banner here, so you can go to it. Science. The idea of sciencewoke.org is to get you to the place of becoming a critical thinker. And, there it is, sciencewoke.org. And it talks about negative numbers and positive numbers. My father does talk about this, and he and I've had discussions about it. And so if you want to read about real world physics and a real world physical model, and why we don't have negative numbers in physics, that it's just a system. And actually another person who wrote about that, which is really good, if you go to problems in science, you click on math. If you really want to read a great book, you want to read a great book, it's the Veritable Number System, in my opinion, one of the genius minds in mathematics. He talks about the problem of dividing by zero and the square root of negative numbers. Quite interesting. So those of you who are interested in finding out that actually our real number system is got real problems, then that's for you. Again, if you have this idea that everything is hunky-dory and everything's cool, it is not. If you take a look at things, you'll find out, in fact, that if you have a critical mind, you'll find out that there are great problems. So again, I have Stefan here. Stefan, if you want to come by and take a look, discuss with me something, pop over into into the comments area, and I do see him in the waiting room. I don't know if it's a person that's, I do bring up people, and sometimes they're just trolls, sometimes, but not always. Okay, let's take a look at this article again. And there we go. Article, we'll share that. Okay, we're gonna take a look at this, and I want to show you guys how ridiculous modern science is right now. And it's numerical evidence for merger of MOTTS inside a binary black hole. So as researchers at the Max Planck Institute of Gravitational Physics, Rochester Institute of Technology, and the Premier Institute for Theoretical Physics, title, importance. So in these articles, they set up their importance, how important they are. So, when these types of articles are written, the idea is to show that these people are intellectuals. And if you haven't seen my video on intellectuals versus critical thinkers, check it out. It's a really great video. And I talk about that, exactly that. And that is, intellectuals are people who are trained in the university and their truths. You have to be schooled in their truths. You're not schooled to be a critical thinker in any way. So that's what they're doing here. They're setting themselves as intellectuals and not critical thinkers, which is just not good from the beginning. Anyways, well, Matt, I'm not going to debate you until you can show that you have any debate skills. So you have none. So, that's pretty simple. Anyways, they collected observations that could offer exciting new insight into the immersion of the marginality outer trapped surfaces. So if you don't know what MOTS is, marginally outer trapped surfaces in a binary black hole, a system consisting of two black holes in a close orbit around each other. There are very close, very dense objects that do, in fact, orbit around each other. And in fact, you can, we do have evidence that, for instance, something very dense is in the middle of our galaxy. And I did a video on that. The video basically states, and I state, that it isn't a black hole. It is a very dense object that does not shine, but we do have no idea what that's made of. It came from the idea, people had the idea that these kinds of things existed because of space-time, but the problem with space-time is it's only mathematical. There's no physics to it. We try to make it physical by making magical words like fabric and foam and those kinds of things. And basically, it became with an infinite point with infinite mass, which is absolutely absurd. It's called the singularity, not the AI singularity. And therefore, these objects were out there and nothing could escape, and of course that's what the black holes are said to be. But in reality, what most of us outside of the mainstream physics or big science, I call big physics and big science, think is they are very dense objects. Perhaps they are made of only the nucleons of atoms with no orbitals, but we're not really sure. And until we're sure, we should call them dark, dense objects and not holes or anything other than like that. Until we know. And of course, then to start talking about their surfaces and the event horizons on these things, again, in my opinion, in many people's opinion outside the mainstream, is that's absolutely bizarre, since we do not have models of the universe that actually give us an idea of what what the universe is. We don't have physical models, and of course we do have physical models in our group. We're trying to come up with those. Some people for over 20 years on that. So it's quite a lot of fun trying to come up with real physicalities for things like gravity and light and magnetics, electromagnetism, all those kinds of things. So we're already talking about objects. People draw pictures, and the idea here, if you don't understand the way popular science or big science works, is that you have this sketch, and the idea is the geniuses sketch their ideas on napkins, and that is something that shows that people are going through this creative process of coming up with something great. How many people, they invented Apple computer in a garage. People wrote their ideas on a napkin, then became a theory, and then they win the Nobel Prize, etc. But that's the kind of thing there. But if you look at it as unappreciated fact that the event horizons are not really useful for studying astrophysical properties of black hole mergers. I can only say to all of this is that we're talking about things, about something we have absolutely no idea what it is physically. None whatsoever. Now, if you're a person who's a physicist who wants to do practical things with physics, you run away screaming, pulling your hair out, saying, I don't even want to get close to these theoreticians. They're nuts. They don't know what they're talking about. They're lost. Wake me up when you have something real. And that's what this is like. So when people who aren't into science a lot ask me, I say, look, the problem with physics today is that people are building a house of cards on a bunch of house of cards. We don't know what light is, gravity, all of these things are. We then come up with crazy ideas of what they are, and then they're working in the unicorn world. Basically, they're studying the migration patterns, the digestive systems, the mating habits, the what they eat, how they behave, all about unicorns. There's only one big problem: unicorns don't exist. So yeah, we can invent systems as human beings. We do that all the time. It's called science fiction. We invent Harry Potter with all the rules we have. We have games. We have video games with all kinds of rules. We can come up with rules. We love to come up with the rules, and we love to live with them. Just because we have all these things that we talk about and there's rules and equations doesn't mean that these things are true. And if you take the time to look at them, if you really take the time, which is my next video that's coming, you will actually find that these things are absolutely rotten to the core. So when we're talking about, they're talking about mergers, and we come down here, and they've been working with 20. Look, take a look at this video. Here's a video. So it's a graph about two black holes, and they're talking about the edges of them. What are they made of? If you asked, if a student who is younger, and you're showing this graph here, you're going to, it's beautiful graphics. You can play it. You can make explanations for it. You can talk about, how they interact. We have no idea what this is. We have no idea. Absolutely none. And you can tell we are lost because black holes couldn't nothing could escape. Oh, there's a problem. Then they found jets coming out of the black holes. Oh, okay. And then Stephen Hawking, after 30 years of working on black holes, he says, oh, by the way, they're gray holes, and they're not exactly, or not very much at all like what I had said in the beginning. So it's really just a a problematic, a whole problematic area of science where we are building on these things. And if you were to take 100 random physicists who do real things in the real world with physics and chemistry, work for the, let's say, for the space industry, and you got them in the room with these people giving these lectures, they would stand in the back just saying, this stuff is all baloney. So, I mean, that's one of the things that is really missing, and that's one of the great things about what we are doing in our a lot of the groups outside. You have the Electric Universe, you have Tesla Tech, you have our group, the Chappelle Natural Philosophy Society. We're all trying to come up with some explanations of the universe. So it's really just quite amazing to me, again, how people don't take the time. If you are a person that just comes in and says, oh, these guys are saying the Earth's expanding, oh, that's crazy, what can you how can you say such a thing? Well, take a look at the evidence. Take a look at the book here. Where is it? Yes, I will show you. Let me get back here. Take this down. I did a video on this. You can take a look at it. This is the most important book ever written about geology, and I will stake my reputation on that. Of course, what does that mean, right? But basically, that's something that I would say I don't say about many books, but this is something. It's really the first tome book to be put together on expansion tectonics, and in a way that's completely geological and written by a geologist, in my opinion, the most important geologist ever in the human race. And he wrote this book, and you can get a hold of it. And it's quite amazing. I got him to actually sign this and give this, send that to me. So I appreciate that, James. But anyways, give me the scoop. So what's up with the plate tectonics save? Oh, okay. Well, I can tell you that. In fact, let's go to Science Woke, and I'm going to show you a couple places where you can read about it first. Problems in science, you can go to plate tectonics, and here you can read about it. We have some very interesting things that we can talk about with expansion tectonics. Basically, if you take a look at the Earth there, you can see this is oh, wait a minute. I'm sitting there talking about a screen that no one can see. Okay, where did I go? I went to Science Woke. I went to plate tectonics, clicked on that, and that's how I got here. Problems mainstream science, and this was plate tectonics. So you can see here on this globe that, in fact, these are expansion ridges along the ocean floor, and that if you take all these expansion ridges away from the ocean floor in pieces in their age, there's only about, I think the oldest is about 240 million years or 200 million years. The entire Earth gets smaller. In fact, I think I have that. We can show you if you haven't seen these. Let me see. Neil Adams, who is a very famous cartoonist, very famous, and he made some money doing that. Here we go. Growing Earth videos. This is the video that got me into it in 2008. I'm going to mute this because you can't hear it. But basically, if you watch this, what he's doing is he's taking away the seafloor bed at increments of 10 million years. And then as he's doing that, he's taking them away as if they've expanded, that the new stuff has come up from the inside the Earth and has created. You can see that when you do that and you do it in the order of the age, you can actually reconstruct how all of the continents fit. And there was somebody actually on Facebook that calculated the the probability of all of these fitting together, just like you see here, and it was like 96 sextillion to 1 that all the continents would actually fit together on a ball. And actually, it even goes beyond. Before that, Dr. James Maxwell actually goes back way further. He goes back to a couple billion years. This is only going back around 200 or 300, 250 million years. Now he's going to come back with it. And so that's the size of the Earth. And one of the consequences of the size of the Earth being that size, it gives us an explanation why in the Jurassic Park time period, an epoch on the Earth, why we have dinosaurs that were so huge and today would die if they were in our gravitational field. In fact, that's another, let's see, I think you can do this. Let's see, there we go. Sorry about that. Make that a little bit bigger. But you can see here, it's very interesting. They say that Africa moved down to the South Pole. It's, in fact, it wasn't Africa moving to the South Pole. It was, here's the South Pole during the expansion. You can see that as expanded, Africa was actually, the continent of Africa was wrapping around the Earth, and that when it broke apart right here, what's really happening is the Earth is expanding. Those ridges you see in the ocean are actually creating new surface area on the face of the Earth, and that's when you plot that South Pole, it perfectly aligns and fits with the expanding Earth. So the less gravity, also again with the idea with the dinosaurs. So if we go back, let's see here, we go back a bit to the Earth expansion, you'll see this is a really the other piece of evidence that's really grand and really great is why the Earth is so big. And Earth is so big. I've lost my train of thought there, but basically why you have giant dinosaurs. And we have Stephen Hurl, and he's written a book called "The Dinosaurs and the Expanding Earth." In fact, let me go to his page here, and here's a very interesting graphic that he came up with for his book. And someone says how from Earth, from the sun. Yes, mass is increasing. Mass is increasing. That's true. We can talk about that as well. But again, this is something we've talked about I've talked about many times in my videos. Take a look at Dissident Science and Expanding Earth. You can see here what he did is 150 million years ago, 70 million years ago, 40 million years ago in present day on the land animals. Of course, if you're in the sea, you can be much bigger because you're buoyant. And if you put, of course, you put the big blue whales on the beach, they will die in a matter of time because they can't survive in this gravity. So what he's showing here is that as a mechanical engineer, he was looking at increasing the size of some pieces that he was supposed to do as for his mechanical engineering job, and that's how he stumbled across this. Because if you look at he ended up writing this book. But if you look at the increase, let's say if you want to increase a cube, if you want to double the size of a cube, you actually have to increase its size to 18 or 8 times the size of the cube. So just doubling an animal in size will actually cause it to be 8 times more heavier, 8 times. So if you want to take an elephant and you want to make a super elephant of double the size, twice as high, twice as wide, it will actually weigh 8 times as much. Its heart's going to have to deal with 8 times as much circulation, and therefore it will not survive. And that's what's happening, showing that with time, what you're seeing here is a decrease of the largest land animals. If you look at, he's got the Tyrannosaurus Rex, way bigger. You have this ostrich type of mimic. You have this, and then you have the little ostrich here. So he's trying to follow something that's very similar. The elephants, the rhinoceroses, you can see are somewhat close. You have the Brachiosaurus, and of course the giraffe. It can only be so big. So that's another person who actually came across expansion tectonics all by themselves and then ended up, he said at the time they didn't have the internet, so he was looking in the library and he stumbled across people like not James Maxwell at the time, but it was Samuel Warren Carey and some other people. So that's what that's sort of about. The other question I had was, is mass increasing? I do want to show you another place. If you want to read the best article, it's not here. If this is the best, let me show you that again. This is the best book. So if you can get this book, I highly recommend it. It's a great read. It's really easy. He does talk about stuff in geological terms, but anybody can really read that. But if we take a look at the Wikipedia, let's see, wiki.naturalphilosophy.org, natural philosophy, we can go to there's 10,000 pages here, believe it or not. And we can go to expansion tectonics, and we have all these articles and things about expansion tectonics. But if we go to, let's see, expansion tectonics, the term, this is, in my opinion, the best encyclopedic explanation for, I'm going to put that up on the banners here. Let me put that up. I don't think I have that here. So this is wiki.naturalphilosophy.org. Add that banner. There we go. Yeah, so go to wiki.naturalphilosophy.org. Click your way into expansion tectonics. And this was actually written by James Maxwell. I did add some parts to it myself on some things that he wasn't involved in, sort of like stuff with Neil Adams. But there are some of the models he built. Here are some of the early models that were built by Kristen Hilgenberg. I think those are still around. Here are some of the, look, he goes way back. Look at, here is the Earth, 25 million ahead. This is the present day Earth right here. Let me get away from this here. Here's the present day Earth right here. I don't think you can see it. Yeah, you may not be able to see it. But anyway, it's the second one from the end on the bottom right is present day Earth. The 25 million years into the future, you can actually see where the continents will be then. And then if you look at the very beginning, that is the Earth, way, way, way back. So obviously, it's not just an expansion with the gases and everything. It's actually an expansion in mass. Now, one of the questions is, if it's expanding in mass, how's that happening? Well, expansion tectonics is supposedly not accepted by mainstream because they don't have a mechanical explanation for the mechanism for expansion. You can see here, he's showing how actually the interior of the Earth, the way he thinks, is how it's working and how it's expanding. And you can see there, but the actual mass increase, let's see, I'll search for it, mass increase, oops, got to spell that right, there we go, mass increase, yeah, there it is, proposal causal mechanism. The fundamental problem that scientists and general public have when modeling tectonic data on an increasing radius expansion tectonics Earth is comprehending where did this huge volume of material come from. So one of the things that they are saying is that this material is actually coming from it's coming from the sun, that the sun is blowing apart atoms. One of the things about being in space and having that harmful radiation is that you're not getting electrons, you're not getting electromagnetic, we're saying it's electromagnetic radiation that's coming at you. That's part of it, but part of it is also the actual protons or the nucleuses of atoms. That's where most all the weight of an atom is. So that's something that so he's saying that it's actually coming from the Earth, the sun, a lot of the mass, and it gets sucked into the poles. In fact, let me see if I can show you that. I think it's chapter 11. Chapter 12, chapter 11. Did he show that? Causal mechanism. But again, no, he doesn't have a picture of that. I think I had a picture of it. But anyways, that's that question. Oh, hey, Be Darkness Falls. Great to see you. It would be correct. So let's see what some people are saying here. Um, he's saying, Be Darkness. Would it be correct to assume 650 million our core was much smaller, thus weaker gravity, but much stronger magnetic field? That's possible. Let's take a look at James Maxwell's interior. I believe he has it up here. Didn't I show you that? I'm sorry to be roaming around here, but I believe he had it here. There we go. Okay, the actual what he is saying here, darkness, v darkness, is that the core looks to be the same. Oh, I'm sorry, can't see that. Got to get that up. Got to look at my graphics there. But there you can see it. Maybe I can click on just that. There we go. But the core would pretty much be the same, and that's really what's building is this. There's a D layer, and he believes that in the D layer is where the protons get combined again with electrons to form atoms, and then they stick, and that's what's the Earth's growing. The Earth's growing, the Moon's growing, Mars is growing. Part of a lot of the expansion tectonics says the Grand Canyon is from the expansion. EU people say that's from electrical discharge. But there are two theories. What's good about it is at least they have some ideas and theories out there. So says, I don't know. Okay, it's just looking at some of these. It says being pulled to the core of the ground, the magnetic core would, just take a look at some of this. Being pulled to the core through the ground or magnetic core would be bigger, gravity much stronger. Okay, my answer to you is, let me see if I can go to Wikipedia here and give you at least one answer. I'm going to show you, I think, a paper I wrote here about something like this. Physical explanation for great expansion. Okay, this was actually a paper I wrote that's pretty interesting using our particle model, because we say that we're a little different from James Maxwell, that magnetic fields are here. Here's a graphic I came up with. I'm going to take yours away here. Again, this is on Wikipedia. Just go to wiki at naturalphilosophy.org. This is a paper I presented at one of our conferences, and I made this graphic here. And what's happening is it blows apart atoms, the nucleon, and whatever goes around it. You can call it the electron, or you want to call it whatever you want to call it. That the magnetic fields are flows of these what people would call electrons. We call it it's a more general particle that's in different places, and that when it gets caught up, it gets sucked up more into the southern hemisphere, and that's one of the reasons why, if you look at a globe, you have more land on the northern side than on the southern side. That would be an explanation. So that was, whoops, there you go. And so if you look at this is, again, what my paper was. It was actually written by myself and Robert Berger. He's a colleague of mine. I work at a LexisNexis in the supercomputing department. That's my real job. And he and I talk about our physics model all the time. He says, Dave, it could be the fact that if you look at the southern hemisphere, why is it there's a lot less land than on the top? Well, our conjecture is that, in fact, that the atoms that are being blown apart, that the flowing magnetic fields are flowing particles. And so for these flowing particles, again, this is our model. Is it right? No. Is it wrong? No. We don't know. It's a proposed model, folks. I'm not here telling you this model's right and anybody else's model's wrong. The only reason I do this is because this is a model I know. Not many people are trying to explain this stuff, so I have to use our model, because most models, even modern models, don't explain this stuff. So I'm using the model I know. You guys can come up with a better model, and it'll beat this, throw this out. Fine, no problem. That's the way models and theories should always be. They should always be disposable. Even Newtonian physics, although Newtonians is pretty darn good. Anyways, what happened is, as you can see here, the atoms are deconstructed. They're flying through space. They are reconstructed. And if the field is moving like this, it's coming through the Earth and going around like that, there's going to be a tendency for the more particles to be caught up and go into the center of the bottom part of the Earth. And this is one of the reasons some of this flip-flops, is because these things are not as pretty as I put them. So the idea is that, and I even asked James Maxwell, I said, how many times has the magnetic field flipped? And this paper has begs a question that I asked James Maxwell that if he could answer. And I said, James, I went up to him and said, James, our conjecture is that magnetic fields are flowing particles, and those flowing particles are flowing at this time into the southern the South Pole, and so you're getting more more mass increase coming through the South Pole. If that's the case, it's going to be more on the south side. And that's why, if you actually look at it, I don't know if I have that. Do I have that? I don't know. I did write a paper. Let me see if I have that paper here on expansion tectonics. Yeah. Anyways, the thing is with expansion tectonics is that if you look around the Antarctica, one of the reasons expansion tectonics, in my opinion, shoots down the plate tectonics model is that when you look around Antarctica, there's only expansion going on. There's expansion going all around Antarctica. And if that's the case, then how can you say the Earth's not expanding? Because where does that go? There's no subduction. The current plate tectonics says basically everywhere the Earth is gaining new ground in the ridges, it's being subducted or pushed under by it's subduction, and that's what James Maxwell talks about here, and I can show you that machine here. So it's being built up in the magna here and being pushed there with the stripes, and then what happens in modern plate tectonics? This new soil here or new Earth crust gets then pushed under. But that can't happen when you have the Antarctica, because Antarctica, let's see if I can go to my paper. Sorry, just keep going backwards. Okay. Well, anyways, I'll get that off now. But basically, what we're saying is that we believe that the magnetic fields are flowing particles, that suns are blasting apart atoms. They're being sent toward us. The magnetic field, which is a flux of particles, we call them, we call light particle, gravity particle, and electrons, magnetism, all the same particle. They all travel at sea. That's our model. But in that explanation, we're saying that, in fact, that's sort of how expansion would be explained using a model. So let's see what else we have being. Oh, look, we did see that. You form a theory from Earth with consideration from the moon and its origin. Okay. You form a theory. Okay, let me look at this. You form a theory for Earth with consideration for the moon and its origin. I don't know if you're talking about expansion tectonics and about the Earth and the moon, but there seems to be evidence as well. If you want to look up, for instance, Neil Adams expanding moon. He does do graphics just like I showed you on the expanding moon. I'll show you that right now. Let's see. I've got to go past the commercials. But wow, almost 100,000 views. But here's the moon. So you're going to see his interpretation of some expansion with the moon. So let's take a look at this. But what he's saying here is that what he's saying is that you have cratering, and the cratering has these lines that shoot out, and those will tell you where some of the expansion would be going on. Now you can see that some of the lines aren't lining up. I think that's what he's talking about. Let me listen in. So what he's saying here is that, in fact, that these mares or very those sheets are things that are expanding. So those, if you look on the dark side of the moon, you don't have those expansion patches, and that this is actually from expansion. Now, I don't know if he actually does any expanding, but
look more closely at their size, at the lack of splash as with the
yeah. So he's talking about that. It's just that.
surface. The craterization is insignificant.
Yeah, he's saying that the craterization in these areas is insignificant. So there's also Neil Adams and Ganymede.
Push the old surface aside and bunched up these.
This is a really good one too. This one is very shocking. If you can't see that this is expansion tectonics at work, then you're really shocked. Look at that. You can see the expanding. So you can see there the expansion over here. So let's see, does he go forward and actually do it? Oh yeah, he does. So he's going to do a little bit of expansion on this because obviously he doesn't have anything except for a two-dimensional graphic. So he's going to do that. But you can see he's trying to take, and you can also see that in expanding how things start to fit together in much the same way. So the whole idea that Mars had water on it and Mars was, once a thriving planet, it could very well be that Mars doesn't have water on it yet and will get water the way the Earth got water. That is the Earth. And you can see again, there's the plate tectonics of the Ganymede. And so very similar to the Earth. And you can see the expansion going on. Now, there's another, he's actually does it in 3D, the whole thing now. So that's pretty cool. I don't know if this is newer or I just don't remember it. But there's actually, then there's the Jupiter has a planet that does even more, just as much. Let's say Neil Adams, Jupiter, Moon, Io, or no, Europa. Here we go. This is pretty cool. So if you look at this, he's just going to do some two-dimensional stuff, and he's going to close it down. So you can see that there are things that have expanded and then things that are on top of it. So you can actually see the order or how it expanded. Now watch this. How is that all fits together? Come on, folks, it is expanding. In fact, NASA is actually admitted and says publicly, it's not fixed radius. It's actually expanding. So this is a really, really good example. And again, he's going to close some up here just using some graphics, and look how that fits together. It's quite shocking. So this is happening on the Earth. It's happening on Mars. It's happening on the Moon. So for those of you who don't know about expansion tectonics, I know I've talked a lot about it. Those people who know me for a long time are probably bored and have left because I'm talking about that. But I will, talk about it for those people who are new to it. Says maybe I missed explanation. My internet is very bad. Let's see. So the planet is adding layers on top of others, where the transmutation is creating matter. Let's see here. So the planet is adding layers on top of each other, from where transmutation creating matter from energy, or how does it work? Well, no, it's not. It's not using layers. It's actually coming up it's actually water's coming up through those cracks. That's how we continually get new water in our oceans. Why is it that we get more ocean floors, but we continue to have water? Because water keeps coming out. It also gives us an explanation of water, because we are supposed to be saying that. Boy, I thought somebody was there. It was actually got my waiting room. Again, if you're interested in actually talking with me, you can, but you can come on by, let's see here, I can show you how to come here. You just go to live.dissidentscience.com and you'll be able to come into the waiting room, and I can put you up here and we can talk and have any discussions if you would like to discuss. So I think I was on this comment here. So the planet is adding layers on top of each other, from where transmutation created. Well, again, what's happening is that it's creating along the bottom of the floor, the seafloor, and it's not really adding layers. It's actually expanding. So part of the expansion, not all the expanding material comes to the surface. It just turns out that because we're getting more mass, the surface will expand, and when the surface expands, something has to fill in on that. So that's the way it's really doing. It's not layers. It's not sort of from the outside. It's from the inside. It's not so easy. Creating matter from energy. Again, let's be careful. Energy is a concept. It's not something. You don't create matter from nothing. And energy is a concept. So you want to really would say it's getting matter from somewhere, but it's, energy equals mc squared is actually not a good equation, because it basically, what is energy? Put three energies in my hand right here. And if you say, oh no, it's right here, well, then it's something. So we just want to be careful. I always tell people energy is a great concept for calculating things between work from one kind of system to another, but it is not a real physical thing. Let's see. One half, can I understand the liquid mantle coming up from the solar? Let's see what it's saying. I can understand how the liquid mantle coming up and solidifying can add volume as the liquid becomes solid and it increases the surface area. But in that analogy, the density. Well, the density is pretty much the same. The only funky thing is that, well, density is density. How much it actually weighs is going to be another thing. So the density would be decreasing. Well, not mass is increasing. I think James Maxwell and his, he has a pretty good graph of this. I think, let me show that to you, I think on the web page. So let me show you that. Here it is, yeah. Okay, I'm going to put that up. There we go. I'll bring that just to the forefront here. Boy, this technology is great, isn't it, folks? This is amazing. Again, if you want to join me, you can. I did have some people talk last week, but anyways, here's the chart, and this is an actual curve of the radius. Let's see, ancient Earth radius in kilometers. This is time. There's the core mantle boundary, which is pretty interesting, and you can see the water. So what's happening here is you can see the increase of water that's coming out. That's water, and oil is manufactured. Oil is abiotic. A is not. Biotic is biology, living. Oil is not crushed dinosaurs. Think about it. How did crushed dinosaurs make so much oil, and how did it get all way down in the bowels of the earth? Methane, oil, and water are produced inside the earth, and they are coming out. That's where water comes from. It doesn't come from comets, and you can see that here being graphed. So that's pretty interesting. Okay, let's go forward here. Something additional, consider possible expanding. Okay, let me just put that up and go through. Something additional to consider, possible expansion from star water created in micronova events. There's more water in Earth than on Earth, by more water in the Earth than on Earth by far. One of the really interesting things is in the last couple years, they've had scientists go down way, way down below the Earth's surface in these mines, as far as almost 3 miles, and they're finding water that is not from the surface, and they're shocked because water is way too deep. Why is it there? Well, expansion tectonics will explain that. I'm not sure exactly what you mean there. Possible expansion from star water created in micronova events. Not sure. Maybe you're talking about waters thrown across the universe and sort of caught. I tend not to think that's really what's happening. I think we have smokers. If you ever seen those black smokers, let me look them up. Black smokers, and we'll look them up in YouTube. And you are going to see water spilling out of them. Well, that's a coincidence. So let's take a look at that. That's not like methane coming out, it's water. So let's take a look at that. There we go. What's that coming out? Smoke? No, it's underwater. So yeah, so we have water pouring out of the middle of the earth. That's where it's coming from, folks. So very, very interesting. That's why expansion tectonics as a theory gives way more explanation than plate tectonics. Not even close. So let's see here. I was stating over time, I'm following the discussion that's going on. I know you guys are ahead of this. Millions of years, such as iron, would slowly make its way to the core, adding to the core, pushing on plates, growing, causing Pangea to break, then push apart. The only thing I would correct you on the V darkness is Pangea is a plate tectonics idea, theory, and with expansion tectonics, you just throw Pangea. Pangea is the idea that the Earth has a fixed radius and all the continents were sort of together, but you have a real problem with Pangea, and let me show you that problem. Other than the show you that Pangea. See if I can get Pangea map, and I want to show you how problematic that is. Hello, 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 hello. Come on. All right, let's see if I can get. Oh, that's not good. Find a Pangea that I think we can. I want to show you a problem with Pangea. How do I just show the? Okay, open that. Open link in new window. Okay, I'm going to do that. There we go. And then I'm going to move it to here. Sorry about that. Okay, here's the problem with Pangea. The problem is they just, an article came out not too long ago, and this is proof. This is proof of how Pangea is wrong. Proof meaning you have to explain something that's extremely damning. On the very bottom here, you see this is Australia, according to Pangea. There's one ginormous problem with this. Right here on this side on the very bottom here, where Australia is, they have found that stone matches exactly on the side of Canada up here. So if you look at Canada between Alaska and the United States, and you look at the very bottom part, the top part, actually it's the top part of where Australia is, they have proof that those are the same rocks, that they are the same age, the same type, and those were together at one time. Guess what? At this time, the expanding Earth, the Australia would be snuggled up, and it is snugged up to Canada. Absolute proof that Pangea is a joke. So when we're talking about V darkness, about expansion tectonics, plate tectonics, we want to say no, Pangea doesn't exist. What's happening is the crust broke apart and started, the oceans started forming. And where was all the water? Well, they are in shallow seas. We know if you see all the dinosaur pictures, they're always in these swampy swamps. So are there planets in our solar system that are the same kind of behavior? Yes, we've answered that. Take a look at Neil Adams. He has expansion tectonic videos on Ganymede, Europa, the moons, those two moons. On Mars is quite good. Mars, you can see the expansion, and he does some, it shows you how that works actually, and it shows you how the canyon was formed, not by electrical discharge necessarily, but by, in this case, it would be for expansion tectonics. Those are two competing ideas. Let's see. Here we go. There's another one. A Theosophist 100 years ago said matter was created by the sun, but not manifested in rocky body planets. Could be. I'm not familiar with that. Not familiar with that. Let's see. What else was a chain smoker racism game? Oh wait, that's funny. Sorry, that's probably something that's not science related, which is totally fine. People are allowed to do that. Let's see. Just wondering. Condensed gases, we're talking about it. Alrighty. let's go on. I'm going to go again, and now I'm going to talk about some more articles here. We looked at the black holes, binary black holes. Let's see. Scientists are baffled what's up with the universe. So I'd like to take a look at these articles, because these are really good points of departure for discussion, because it also tells us where things are. So here it is. Scientists are baffled what's up with the universe. I always love these things. And in the beginning, you're thinking, oh my gosh, it's great. This is a pretty famous graphic here, or picture. This is a deep, it's called the extreme deep field. They actually took Hubble at the time they came up and pointed it into dark and deep space where they're expecting to find nothing, and they found gajillion galaxies, and they're way more mature than they're supposed to be. But right now, I guess, the universe is only 13.78 billion years old, which is quite amazing to me, because in my opinion, you can't have things go away and come, the Earth, everything's been here for a while. It's forever. It's a constant soup of changing, but it doesn't go away or come from the size of a pea or something like that. In my opinion, the universe doesn't look right. It suddenly looks out of whack. No, this reminds me of this, which I will put up too. See if I have that. Science woke. I'll put this up. The memes. It's one of my favorite. Here it is. I'll put this up. And when something's out of whack, I said the universe isn't complicated and paradoxical. Our theories are, and this must change. So I thought I'd put that up. Okay, let's get back here. And they're talking about how, the universe doesn't look quite right. Is a strange message coming from astronomers and physicists who are wondering whether they need to revise cosmic history. You think? But of course, normally these articles end up, no, we really don't. We've been right all along. We just have to tweak it. We could never be wrong, and that's the main theme always. The universe is unimaginably big, and it keeps getting bigger. That's crazy. The universe, linguistically, folks, the word universe exists in many languages. In fact, it exists as the same word in a lot of languages. Universo, universe, universe, all those words, universe. And the idea to have in human language a word for that, it means everything. You can't have parallel universes, because the universe is everything. Everything that we know exists is in the universe. So you can't have two of them. You can't have parallel of them. It can't be getting bigger. It's everything. It always has been everything. So this whole idea of using language in this poetic way is non-physical. So I just want to point out to you that the universe is unimaginably big and it keeps getting bigger. Not right, in my opinion. Many of us. But astronomers cannot agree how quickly it's growing. See, there you go. It isn't growing. It's always been there. Let's say, even if we have mass going from a small point in the Big Bang going into something, that into something, they say it's creating space-time. Well, what's on the outside of it? Nothing. So, there you go. 9 decades of astronomer Edward Hubble showed the universe in orders of magnitude vaster than previous. Imagine, isn't that interesting? Did you know that in the beginning of the 20th century, the universe was only a couple million years old? Then it got to be tens of millions, then 500 million, and then it got to be 1 billion. Why? Every time we got better telescopes, we saw further out, and we had to revise what. So our rule of thumb mathematically for the universe is basically, it's as big as we can see, it's as old as we can see. So the universe gets older as we see further. No one is panicking. To the contrary, the theorists are intrigued. See, there you go. Remember what I said? I haven't read this article. Remember what I said? They're always going to say, big crisis, oh, but don't panic. We always have everything under control. So there you go. What are you going to do? How long is it going to end? Is that a big question? Hubble constant is there. The number has to be 0. So So what is this guy? I always laugh at it. I mean, what's the unicorn world talking about today? I mean, they write this stuff with a straight face, right? Anytime there's a discrepancy, some kind of anomaly, we all get very excited. The Hubble constant is a central feature of any theory, and about the ultimate fate of the universe. There you go. The universe is always here. There's no fate. It's always here. So let's get over it, folks. It's not, unless you believe in mystical things and not a physical universe. So So, anyways, not to me, it's not even interesting to go on with this particular one. There was somebody who came in with live and then they went away. Hey, V Darkness, you want to join in a conversation today? I know you've got your, everybody can be busy. Maybe you're just looking around, staying, but alrighty. Let's take a look at another article here. Physics splattered blood, origin of heavy elements. Kites that generate electricity, physics of splattered blood, origin of heavy elements. Oh, this is pretty interesting, perhaps. Origin of heavy elements. Let's see that one. We have the Sapphire experiment going on, and then the Sapphire experiment with thunderbolts. They are showing that they seem to be making very heavy elements creation with electrical discharges. So we will see there. But anyways, take a look here. Oh, got to unlock this. It says, finally, we have marveled at the fact there's recent study that light from a merger of two neutron stars is the first spectrum evidence of neutron stars, mainly mostly neutrons. That's the same light confirms that such mergers are origins of some of the heaviest okay, there it is, talking about it. So they're talking about neutron stars. One of the things is, even in modern particle physics today, there are lots of people in modern particle physics physicists who say neutrons do not exist. A lot of our models don't have neutrons. We have, in our model, we just have, there are no such thing as charged particles. Particles move toward each other and away from each other because of physical forces. So anyways, that's interesting, talking about neutron stars. I was thinking maybe they're going to be talking about, other than they saying some of the heaviest metals are coming from that. So anyways, there's somebody, T. Kleckner. You want to come into the room here? I would love to, but my daughter's teething. Yep, I believe it. I also have to make sure, that's why I do it on Friday nights, because I don't have any competition. My daughter, who's in theater, starts singing and it gets pretty loud, so no problems. Here is a question I can answer. Again, T. Kleckner, if you'd like to speak, maybe if you can get your video going, or if you just say, hey, I'd like to, in the comments, I'll bring you up. What are your thoughts on metaphysics? I do have thoughts about that. And hey, no neutrinos, Dun Raven. Sorry to put that there. I'll come right back to it. No, yay! Another no neutrino guy. Absolutely true. Read Carazani, Dr. Carazani. Okay, what are your thoughts about metaphysics? It is interesting thought about that I have in metaphysics. It's not going to be how you think about it. There's things that are going on in structural levels that we don't understand, or maybe don't even have physicality. I don't believe in that myself. I'm not poo-pooing anybody who does believe that. But the way I look at metaphysics is more in a philosophical sense, that we look at systems of how the universe may work. And metaphysics literally being a system of of theories, or the system like infinity, for instance, to me is a metaphysical idea. But that's not a metaphysical idea in the sense of the colloquial way. So metaphysics is really a philosophy, and the philosophy of science called natural philosophy is very much interesting to us, but not in the same way. But philosophy, again, it's really important. And one of the philosophies I adhere to is infinity, meaning there's no smallest particle. You can keep going down, and a particle has parts, that part has parts, that part has parts, all the way down. So maybe it's not exactly the how do you say, answer that you would imagine, but hey, look at this. Dunn says the no neutrino, right, correct. Invented particle, right. It was invented by Pauli and named by Fermi and Dr. Carozani. If you want to go to that, go to autodynamics.org. Let me put that one up there. HTTP. You can actually go to neutrinos.autodynamics. He is my mentor. That's how I got into all of this. So here it is, neutrinos.autodynamics.org, and you will in fact read about the real reason why there is no neutrino. But Dunn-Ravin, absolutely. Maybe you're somebody I know with a fictitious name, because when you come in, well, I guess when you log into YouTube. But anyways. Okay, getting back here. David, did you see the, okay, here we go. Did you see the Science article yesterday about ether and Einstein and relativity? I don't think I did. I think also V Darkness sent me it's something that I really would like to talk to him. I'm thinking about maybe talking to him directly, because he will come up and talk. So let me look that up. You say New Scientist, Einstein and Ether. I think I did actually read that. Yeah, I did see that one. But let's take a look at it. It's something good to look at here. Einstein killed the ether. Now the idea is back to say relativity. Well, let's take a look at that. Just that. I know people are not going to like what I'm going to say, but I will not lie to you. Ether is not the only solution for light. It is a light-centric solution to light. And there are more general. We have a particle model, and it's more general. And it doesn't have the same problem as ether. So let's be very clear that this is not the only choice. I'm going to say that again and again. Ether is not the only choice for light, a physicality for light. So first of all, Einstein killed the ether. No, ether is still a viable physical mechanism for light, but it's not the only choice. So there are lots of people who don't look at the others. Don't look at the other models at your own peril. Because if it turns out that my father, for instance, who came up with a really brilliant solution for light that doesn't have the problems of ether, it may, who knows, my father's model may win out. And where are you? You're stuck on a place that maybe it won't be the answer. Is what I'm saying, is that going to happen? No, I can't predict the future. But I am here because I'm your science therapist. My job is for you to stay critically thinking and for you to also realize that when you read these things, you assume there's ether, and I think most people in their minds, those people who really know particle physics has problems, that physics has problems, that we don't have physical models for anything. All you people, I'm sorry, don't mean to say that at all. All the people who are critical thinkers and are looking for new models, no, ether is not the only other choice. Light can be modeled very simply in a much more digital way, just the same way that today we don't use waves, we use digital transmission of light in fiber optics. So Einstein killed the ether. That's true historically, but it doesn't mean that ether is the answer. It's an answer. Now the idea is back to say relativity. Now there's a second sentence. See, I can't even get by the titles. Now the idea is back. Okay, that is a theory of ether. Okay, that's okay. The theory that's one idea is ether is back. That's fine. To say relativity, no, it's not going to say relativity. Now, if this is general relativity, what it should be saying is Now there are people who are reviving the ether theories, and that will not save relativity, but replace it. We don't need relativity. So this is just full of all kinds of problems. And I'm sorry I'm sorry, Ned. Ned, I don't mean to. This is no picking on you, Ned. I'm trying to give you my opinion. That's what you're asking. So I hope you're understanding that. I mean, we can go through this. Says as far as the idea of luminous ether is among, as far as dead ideas go, the luminous ether is among the deadest. So this has to go back with ether, Michelson, Morley, who tried to find ether, and what they were trying to do is thinking that ether was sort of a stationary reference frame in the universe where we move through it, sort of like water sitting in water, and our planets and our suns and galaxies move through a water, and we're going to detect that movement. Well, even in ether theories, if you believe in ether theories or you subscribe to ether theories, that's what I should say, that's not necessarily true. But regardless of all that, that wasn't, Michelson Morley supposedly disproved ether. That's not true. Then Einstein came along and says we don't need it, and here's why. If you look at how he did that, that was not done correctly, and relativity is wrong at many levels. So. But relativity has run into difficulties of old. It's failed to explain behavior of the universe at small scales. How about the behavior? How about the biggest scales, like bending light, which it doesn't if you're talking about general relativity? How about that? And of course, I've talked about this over and over, and that's Dr. Edward Dowdy from NASA, who says, guess what, folks? Light does not directly bend, gravity does not directly bend light. So again, on and on and on. I'm not going to go through this, but that gives you an idea. I hope that helps answer your question. Okay. Where were we? Okay, let's go down further. Next one. David, I'd love to read more on Pangea debunking, more things I can correctly teach my daughters as they grow up. Oh, this is a funny story, Darkness. I call you, it's really heavy there. I'm going to call V, no, I was going to call you VD. Can't even say that. That's an old term for, no one say, hey, Falls. I'll call you Falls. Hey, Falls. But anyways, Dark Falls. Interesting about my daughter comes home to me many times and has to learn about plate tectonics and all the silly things that they talk about. And she comes and goes, Dad, wait, I know you don't believe in all this stuff. I know you think it's wrong, but I got to take my test and pass it. And that's exactly the problem. But even my family, there's times where people, they think it's crazy. But yeah, expansion tectonics, I wasn't aware you didn't know about that. That is, if I were to pick anything, I would stake all my reputation and money on, for sure, expansion tectonics is correct. There is just absolutely overwhelming evidence. It's extremely fascinating. Once you understand how expansion tectonics works and all the levels, at all the levels it works, you can't go away. You can't get out of your head after that. It's gone. It's done. Say, do you believe we could be living in a computer simulation? Philosophically, I have thought about that. Are we in a big experiment by some junior high kid of some super brainy race? I think the way I look at it is this. I think those are valid questions when we have valid or decent physical models for light and gravity and magnetism. I can't really say to anybody that I feel that we are gaining much when we have such fundamental problems in our science right now. I would say it's interesting to talk about, but to me, it's much more interesting to talk about a model of the universe, than it is to talk about necessarily where they're in a computer simulation. I know it's interesting to you, but man, you should take a look at some of the new models being proposed. They're quite fun. So could we? In my opinion, probably not. I just don't see that. I don't, and I've thought about these kinds of things myself. Like if you take away my body and replace it with electronic parts, will my supposedly ego soul or whatever continue being there, or is it gone? Is it something else? My consciousness goes, I don't know. Those are interesting questions, but in my gut feeling, I would say no, and I think infinity would answer that question. Read Borkert. I think that's where I would say an answer would be, and that the structures get infinitely bigger, up and up and up and up and up and up, and things get infinitely small, down and down and down, just like the fractals you see, very much such similar to that. Let's see. I don't know you personally, Dave. Would love to chat sometime, though. Okay. Yeah, no problem. Oh, okay. I got you. I did mention, hey, how did he come up with no neutrinos and invented particle? That's really great. So I thought maybe he knew me because there's not many people who say those things, which is true. Justin, well, I'm an ether man. That's good. But Justin, remember, it's not the only answer. And the other thing is too, and it's in my video that I'm never finishing for 2 months, is that there are problems with ether. There's problems with but the people who do ether theory seem to not address those problems. 20 years ago, when I first started hanging out with these great minds of critical thinkers in the NPA, which is now the CMPS, there were quite a few people who were constantly on ether people saying, okay, how do you explain ether's elasticity? That's so ridiculously elastic, right? If you're going to go 10 billion light years and spend 10 billion years doing collisions all the way, look how fast sound goes away. Sound in the air, it doesn't go all the way around the earth. I'm not talking to you and you're listening by sticking your head outside the window. Imagine now that you have to have some type of substance to which when those things bump against each other, that transmits a wave for 10 billion light years. That is a problem with ether. Another problem with ether is transverse waves. And again, people talk about them and they said they've solved them. I've looked at their diagrams and they don't. So those are the two big things that you have to solve. So if you're an ether man, you are putting yourself with those problems. You have those come with you. So, but again, I respect you because I would rather be an ether man than a standard particle man any day. I call it the Planck C. Okay, that's interesting. Cool. Einstein went back to ether in 1929. Yeah, there's some speculation about that. Some, interpretations of what he's saying. But again, what if the particle model is a better model and it works? Then no one will be talking about ether. So careful. The other thing too is we do spell ether in English and orthographic systems as AETHER, AETHER. The reason is this type of ether is actually a gas, and if you breathe it in, you'll laugh a lot. Let's see here. But digital isn't free-flowing in all directions. It has to be constrained down to an isolated path. Not sure what that meant. It's probably something I said a while back, and I not for all these Rick James calling me okay. The worst part is that we grow up into scientists. Okay, let's see this here. The worst part, if you grow up and be scientists, they have to go along with the Einstein theory, or they won't have a job. Sure. Yeah, that's absolutely true. Dr. Karazani had experiments for a couple of grad students, and they that would show Einstein wrong. Their grad student professors shut the door and says, "You want a career in physics? Don't do this." That's horrific. It's just horrific. Shouldn't happen. Let's see here. Definitely some invisible force. Take some strong nodium magnet back up to the TV. Okay. Talking about magnetics, there's definitely some invisible force. Take a strong neomagnetic camera back of the tube of the TV and shake the magnet violently, and you'll see what happens on the TV. Instant action at a distance. It isn't instant action. It's actually measurable that it's got a delay. And again, we have a particle model can explain all that. So if you have a model that can explain it, then it's not so spooky and it's not really invisible force anymore. I know what you're saying. I'm not arguing with you. I'm not disagreeing with what you're saying. I'm just interpreting what you're saying. If you have a model, it will explain that. It isn't instantaneous by any means. It won't be, but that's something that doesn't happen in the universe. Instantaneous travel at no way. Dave, did you read any Peter Plitschney, multidisciplinary German scientist? He gets much press. Let me look him up in the Peter Plitschney. Interesting. Let's see, he's coming up here. Articles, research, Amazon. I guess he has a book. Let me look here. Let's see. Holding doctorates in chemistry, physics, and biology. Peter Plichta applies his multifaceted scientific knowledge to search for a universal binding plan and makes profound discovery. Plichta shows a mathematical formula based on prime numbers underlies the mystery of the world. It's interesting. I've read about these kinds of things, obviously, and I will say I'd have to see it to understand. I think I tend to look for physicality and mechanisms, mechanical explanations more than mathematical ones. So I'm sure it's interesting, but again, I guess I personally wouldn't take too much time to look at it myself because I'm more interested in us continuing to try to struggle and find real explanations for a magnetic field, for goodness sakes. So yes, I think that's interesting. I'm into systems. I'm a mathematician, actually. I've got a bachelor's in advanced calculus. Love math, but math is in physics. Math, it helps us with making predictions about the physical world if we have models that somewhat work. So interesting, though. Interesting. Which answers questions that have baffled mankind for ages. Well, okay. That's interesting, too. Those are claims, of course. The only thing I can say is that when people make those types of claims that they've come up with one thing, I start to get a little bit dubious because the moment what I do is I start reading and I find there's no physicality. It's all a mathematical system and it comes from numbers. And then you get into people starting to talk about metaphysics at that point and saying, well, maybe the universe is really guided by numbers, and that's not true. Our numbering system is actually flawed. The square root of -1. Again, read The Variable Number System by Peter Erickson. He's got a great book on that. Look it up. It's not that expensive. Well worth your read. Ethers are a functional group. He explains geometry and masses, transport, reciprocal geometry. Yeah, again, I'm more looking for the physicality. So that's interesting, but I wouldn't myself spend much time on it because, again, we have too many other things I'm looking for physical explanations for. But that's my thing. That's cool. If you can model all these things from his mathematics and make predictions and tell us how everything sort of works in a physical way, great. Let's see. Please look up Edward Dollar while you're at it. I think I have looked them up. Let's see. I'm not sure. Dollar's interesting. I like electrical engineers over. Hey, Justin, you and I are in absolute agreement. I like electrical engineers. Believe it or not, the best critical minds and best people who model things, and the most biggest skeptics, the ones who have the greatest attitude of, look, all of our theories are junk. It's just some are less junky than others. have been electrical engineers. My father, brilliant scientist, electrical engineer. A lot of people I know in our organization, electrical engineers. Yes, absolutely. I don't know about Dollard's. Maybe if you can give me some um, sort of reference with that person, Dr. Raymond Rife. Say, I don't know, Dr. Raymond Rife, who has seen research reborn in double frequency vibration targeting, destroying different cancer cells. Boy, do I have a whole different idea on that. Hey, Kate. Hello. It says, hi, Dave. Kate Rame. Okay. Sorry, just a question of topic discussion here. Oh, must have been here before. Well, we sort of been, I sort of take articles and I take questions by people because that's what this is for, sort of interact instead of me making a sort of a script and talking about things. Dr. Denver Rife, have you seen research? I am a person, you're going to get my real answer. I'm on a whole plant-based diet. Human beings, if you read about it, if you want to go to a real science about nutrition, this person reads every English language nutrition paper on the planet. Literally, I'm not kidding. Nutritionfacts.org. And with that, where is it? Where'd it go? Did I run out and they don't have as many? Yeah, there it is. Nutritionfacts.org. Cancer, your white blood cells kill cancer every day. One of the studies about white blood cells, cancer. There were 5 places in the world called blue zones. These are not. This I'm not here to preach on some diet like high carb. This is science talking. Basically, they found 5 places called they're blue zones. Look them up: Okinawa, Sicily, Loma Linda, California, because they have a religious group there that eats whole plant-based diets, and they all ate the same diet, whole plant-based, no oils, no dairy, no meat, very little of any of that, if any, and no disease. People lived into their 90s and 100s fully functional, drop dead mowing the lawn at 105, like one of these people who just did, actually 102, I think. It turns out that we eat junk, the number one killer right now, and this is a fact. Look it up. This year, the International Organization for Human Health has declared the diet as the number one killer. Basically, take women who have 4th-stage breast cancer, put their blood on top of a petri cell of cancer cells. It will kill about 20% of them. That's not enough. They will die of cancer. Put them on a plant-based diet for 2 or 3 weeks, or maybe even less. What happens then is that they drop the same woman's blood on the same cancer. It's now killing 70 to 80%. So we kill cancer. The way I look at it is we shouldn't be spending our time worried about killing cancer we should eat healthy, and then cancer doesn't exist. In these blue zones, there is no cancer, there is no heart disease, there is no diabetes, there is no dementia, there is no arthritis, there are no allergies. Yeah, people do get them, that's true, but in general, no. So anyways, that's my answer on the cancer part, and I'm sorry, but that's, I'm going to tell you what I really think. I know because I risked my heart disease. I had heart disease and allergies and arthritis. I have none of those. I'll be 60 this month and don't look 60, good shape. Why? Because my diet is really the healthiest diet you can pretty much have. And that's, again, not discovered. It's discovered, not invented by human beings. Preaching over, but that's my take on it. B1 and B12 required, and now it's time for working on killing cancer. Again, good diets kill cancer. In fact, if you are catch your cancer enough ahead of time, even if you're in late stages, if you want to read books, see the movie Forks Over Knives, Cowspiracy, that's a good one. Another one that just came out by James Cameron. James Cameron's on this diet. Millions of people are moving out of the diet. Anyways, yeah, Justin, if your diet is atrocious, that's where you got to start. But hey, I'm not here. Everyone choose to do what they want. I'm just telling you scientifically. Go to nutritionfacts.org. It will tell you everything. If you go to my website, Gosh darn it. I have so many websites. If you go to my website, you can actually read my story. My story was published as well at Forks Over Knives on an international website. Let's see here. So if you go to my website, you can read about diet and all that stuff. They're very interesting. A lot of scientists. Aristotle says the best way to keep the doctor away is through your diet. So people have known that for thousands of years. Okay. Triangle glass cancer theory. That makes sense. Most of our teeth are flat in our jaws. Yeah. Basically, another a really good one is Mike the Vegan, Micthe, the vegan, Mike the Vegan. Look at that. He is a really good. He's a more modern guy about this. But hey, they've done this over and over and over. There's a famous guy, Esselstyn. He goes to firehouses where all the guys are, fight. They're firefighters, and they've got cholesterol that's as high as 300. They don't want to die of the heart attacks. They're in good shape, but they're dying of heart attacks anyways, even though they're in super great shape. He's going around changing them to plant diets, and in 7 days, their cholesterol falls 100 points. And then within a year, their heart disease and diabetes, they go away. Diabetes number 2 is 100% from what we eat. And again, I'm not here, but read on it. Don't believe me. Go to nutritionfacts.org, watch the documentary Forks Over Knives, etc. Had a friend. Oh, you want to hear a story on diet? I wrote about my diet in our organization, LexisNexis. Again, I work in the supercomputing department here in Boca Raton, Florida. I wrote my story. A lady in North Carolina saw it. Her mother had diabetes for 15 years, tried a vegan diet. Vegan diets are not healthy. They are good for the planet, good for animals, not good for people. But so she tried she had 15 years, she had diabetes. She went on the whole plant-based diet. 3 months later, her doctor says, you have no longer diabetes after 15 years. Her father didn't believe all that was going on. The entire family changed their diets, were doing super well. She was a runner, was running she literally ran a marathon within a couple of months, not having run for a long, long time, because she just said, keep going. Her father, literally, this is no lie, this is the story. In August, I had just talked with her. We're going to do a podcast at our company. Here's the story. Amazing story. I helped this person. I feel very good about it. I'm not here to be right. I don't care about being right. I care about people getting truth. Here's the story. Her father calls her up, says, I'm in the hospital. I'm not lying. I'm not making this up. I have 2 to 5 days to live, they told me. I said, I didn't want to be in the hospital. I want to come to your house because you're my oldest daughter and I'm going to die there. Can you help plan my funeral? She goes, I can, but I can't cook a different meal because we cook whole plant-based diets at our house. Literally comes to her house. He has 2 to 5 days to live. She cooks the whole plant-based diet. Within 2 days, all the pains that he was having, which was complete pains, he was a walking heart attack, diabetes, he was obese, everything was wrong. Within 2 days, all of his pain almost went away. He felt so good, he kept eating. Within 5 days, he said he had never felt as good as that in 10 years. 2 months later, he's completely alive. He said he'll never change his diet ever again. And again, it's not a diet that's invented. It's pretty interesting. I have another channel name that I want to talk about science. I won't give you the name because I know not everybody's the same political bent I am. But anyways, it's quite amazing. If you are having problems, when I was 53, I ended up with heart attack symptoms. And I said, enough is enough. My doctor said it was genetic. I didn't believe him. It wasn't. How could it be genetic? I changed my diet and it's gone. My heart disease is gone. All right. Eczema, that's also from what you eat. All right, Dr. Yeah, yep, you got it. Furman and Esselstyn, heroes. And how can we make hoverboards real? When we have a model for gravity, and we have a physical model for gravity, we have a physical model for light, we have a physical model for magnetism. We could perhaps do that. Until we do, we're not going to. We're not going to. So the answer to your question, can we make hoverboards? We don't know because until we get a model. So the answer is moot until we all agree on, let's build a model. Let's get to a model that we can agree on. They say light, say relative to light, space got shrunk into two-dimensional perpendicular to the light's direction. Guy, no offense, and unknown. This is all babble speak. It's babble speak. If you can tell me what light is physically, and I'm saying this over and over, if you can tell me what the basic things in the universe, which the standard model can't tell us, if you can tell me those things, I'll start listening to you about these things. But until we get there, this doesn't mean anything, because two-dimensional, everything is three-dimensional. There's no two dimensions. Even our two dimensions, three-dimensional. Here's a piece of paper. Oh, it's two-dimensional. No, it's three-dimensional. Okay, so it's just mathematics. It's a good question, though. Interesting. This was cream. Now they're talking about health, Steve. So clear it up. Okay, there we go. But that means space has relative velocity. That will mean relative to every object. Space does have definite velocity. Okay. All right. The only thing I would say, let's look at some of the sentence here. I'm a linguist, first of all, so I can break sentences down quite well and parse the sentence into a structure tree if you want. But that's not what I'm going to do. I'm going to talk about the meaning. Space does not have definite velocity. Space isn't anything. Its purpose in our language and in hundreds of languages which have the word space is nothing. It's purposely there to describe nothing. You can't take, it's like saying, oh yeah, the bowling balls that I use for that fly through the air, they come to my house and they fly near my window and smile at me. You can say that, but bowling balls don't do that. So just because you say the word space does have definite velocity, maybe you need to reword your sentence. Maybe you have to say that in space, there's a finite velocity for mass. Okay. For instance, the only mechanisms that we use to accelerate anything today, even light, if we use lasers, is the speed of light. So can we go faster than the speed of light? No, we can't, because everything we have and know about is faster, is speed of light or slower. If you have a model like we have probably c² or at least super high speeds, way faster than the speed of light. If we could use G2 particle acceleration, yeah, we could go past the speed of light. Of course, we don't know if the atoms would stay together, but those are all questions. Familiar with Walter Russell? Not sure. Walter Russell. Let's see. Oh, interesting. Let's see here. I can put that up. Walter Russell. What is he? Born in Boston, Scottish immigrant, Russell School. Oh, wait a minute. Okay, wait a minute. Here it is. Impressionist American painter, sculptor, musician, and author. Writing person of the New Thought movement. Okay. Okay. Oh, my daughter is singing. I apologize here. I don't know if this is the same Russell, but let me know. Let's see. Can you riff on your understanding of gravity for a minute? Oh, okay. Sure. Here's the way I would talk about gravity. First of all, what is mainstream saying gravity is? Well, they have a problem in the sense that if you look on standard charts, you're going to see graviton, but then you're going to hear about space-time. And space-time is a foam, space-time is a blanket, space-time is space can bend, space-time can bend, and those cause gravity because mass causes those bends. So you can pretty much, except for the graviton, in my opinion, the graviton sort of hangs around. All the other stuff you can throw away. Because until you give if you were to give a physicality that is, let's say, space-time as particles, then that would be something. Gravity today is described, I would say, in two general ways outside of mainstream science. One way is the graviton model, which is the older model. which is called ultramundane corpuscle. And basically that is gravitons, and that is gravity is a bunch of particles moving in all directions, and that there's a shadowing effect. Let me see if I can get to that here. And so that's one way that people talk about gravity. And I'm talking about outside of mainstream now. I'm riffing on gravity, meaning right now I'm talking about gravity in the sense of outside the mainstream. And one of them, the older one, is in fact, wow, failed to parse. Ooh, I've got a error there. Okay, let's see here. Do I have that? No, I don't. I don't have it here. I have it in our book. Maybe I can show you my book. I'll take these out because I'm not needing them. I have some really nice diagrams in here. Here we go. Why don't, Dave, you have this book? Look, it's the universe hack, the particle model, an older one. Okay. So here's a picture. And what you see there is the sun and the earth. And you see little particles all around them. They're going in all directions. Well, when you have particles going all around in directions, imagine ping pong balls flying around the earth and the sun. They're flying in all directions, but maybe golf balls because they're heavier. And what happens is when you put them together, put two things together, it's going to block some of the things hitting on this side. So there's going to be lower pressure here. So there's going to be more force on this side than this side, because when you have a body sitting here in what's called a graviton field, which is with gravitons, particles moving in all directions, this is going to pretty much stay where it is because it's going to have equally amount of particles hitting on each other. That's graviton model. If I put another one next to it, another object next to it, what happens is you're going to get particles on this side that are going to hit, but you're going to get less particles here because this is in the way. So this is in the way. You're not going to have as many particles hit here. If that's true, then you're going to have a net force that's toward each other. So that's one way. Now, another way that there's two other ways. One is ether, and people have various explanations for ether gravity. I won't try to get into one because it's complicated. Now, why is it complicated for ether to describe gravity in a physical way? It's because ether, and this is David D. Hilster speaking from my own experience, ether is a model for light, and people who come up with ether theories and fall in love with ether is the way I put it. And there are a lot of people, in fact, there's some people here that are having an affair with ether, in my opinion, and instead of having a more cold and standoffish, okay, it's one idea, is that the ether theories spend all their time trying to figure out how to make gravity work in the ether. So they do try to do it, and there's a myriad of but I think they're trying to take a smaller an ether theory, which is only for light, and make it work for gravity. And I don't think that's the right way to do things. Another one's called an extra force that's left over from like nuclear forces. So the things that keep atoms together or keeps molecules together, it's at a subatomic level, that there is some force that's extra that's still it's left over. A lot of times it's electromagnetic or it's charge. So there's a little bit of charge left over, so that would bring things together. But of course, in my world, in my opinion, that's not good either, because what happens is that you have to then explain charge. Charge is not magical. You can't put a plus on an electron a proton and a minus on an electron and say, oh, they magically come together. But that's what we do. And same with magnets. Oh, it comes with an invisible force, as V darkness says, but that's not invisible. So that's what gravity, in my opinion, we have a model for gravity, my father and I. It's a gravitonic model, but that gravitonic model also explains light, not light, but the same particle can explain light, but it's just the different behaviors. In our particle model, as an example, because that's the only way I can talk, because I don't know of other models that can explain physicality of things, is that light travels at the speed of light. Obviously, gravity travels at the speed of light. If you look at eclipses during the sun, you can actually find out that the gravitational force and light come at the same time during a full eclipse. 3, you've got electricity flying at the speed of light, electrons flying at the speed of light, at least in electric circuits. And we think also that magnetism also travels at the speed of light. So what do you have? You have a particle you have all these particles traveling at the speed of light. Then why isn't the electron, graviton, photon, and magneton, I guess just made that up, all the same particle in ours it is. So we think of gravity being, in our model, gravity is a random field of like particles with bodies that are bigger than those particles in that random field. So anything, in fact, we think gravity can happen. It does happen at the lower level. What keeps an electron going around the nucleus of an atom is smaller particles even than those particles. And gravity in our model are, again, random particles moving in random directions that are similar, that have larger bodies within them, and that is a gravitational field. That's my riff on gravity. So Walter Russell speaks about light and how it works. Okay. Yeah, I mean, I'm not sure where that is, but I try to look that up. There we go. You sound schizophrenic. Okay. Well, sometimes people's ideas are still there. How do we eat green yet get healthy amounts of cholesterol in us? That is important that our cell lining. Guess what? We make cholesterol. Most animals don't. That's why we have high cholesterol, because we eat stuff with cholesterol in it. So our bodies produce cholesterol. Go to nutritionfacts.org, look it up, or you can just look it up in general. Our bodies produce cholesterol. So again, nutritionfacts.org. They look at real studies. There's only been one clinically proven diet. And again, it wasn't invented, it was discovered. They discovered populations that live without any chronic disease. In fact, the United States had no heart disease until the early 20th century. Did you know that? The first people to get it were the rich people, because they had refrigerators and ate the crap that we eat today. It's interesting that we call the standard American diet SAD or SAD, which is quite ironic. Let's see. I like Walter Russell's periodic table. Oh, okay. Walter Russell's periodic table. Let's take a look at that. Walter Russell periodic chart. Oh man, it comes up, doesn't it? There's actually quite a lot of periodic charts that we have in books. Quite good. Let me see here. The only person who has more dissident books than me is, well, that's not true anymore. I may be winning now. Oh, here it is. This guy met some. There's an atom, according to his, and you want to see a wild periodic chart. Look at that one. This is a completely new model of atomic structure. I love it. You know why I love it? Because they're trying. This is better than mainstream physics, because they're trying. Yes, in time, space and time, nothing existence. Okay. Oh, I was looking at that. Oh, periodic table. Sorry, got distracted. Oh, wow. All right, here we go. Take a look at it. Why am I getting two of those? That's weird. Okay, here's what I'll do. Sorry. There we go. Let me get this out of the way. Lithium mirror, the 5th octave, 6th octave, 7th octave. Yeah, okay. Let me explain this. I can explain this to you. And it isn't the way you think it's going to be explained to you. But basically, what you have is a system. He calls it octave, octave, 3rd octave, 4th octave. There is a system to atoms. You can classify them and make them into many different types of charts. That's absolutely a truth. The trick to me, though, is to actually tell me what it is. You know, you can make a different system, just like you can make the map of the world that's on a sphere into how many different types of projections. I think there's at least 20 or 30, no lie, 20 or 30 projections of how you can draw the spherical map onto a flat surface. Are they any wrong? Are they right? No, it's very interesting. Now, if he then can come back and say the atom is made up of spherical things or made up of donuts, toroids, and they're arranged this way, cool. That's great. But the way I would say is this: yes, you can continue to make systems and mathematical and octaves and this sort of semicircles that get bigger. You know what the average person on the streets wants to know? What is it? What is it? And again, I'm not here to say that's not interesting. I'm not here to tell anybody, like, don't give me this junk. No, not at all. This is super interesting. What I would like to see is that if a person comes up with a real physical model, would this have any revealing aspects of that physical model in his diagram? Sometimes these systems will actually reflect something that is actually real. But I would say, give me the real physicality. Says, yes, I know what you're talking about. Space is nothing but in existence. Very good. I agree with you. That shows flaws in relativity of Albert Einstein. Yeah, well, there's quite a few. The special relativity and general relativity have major problems. Yeah, I do too. We just take a look at that. Because Cookie said those things himself. That's so shameful. Well, Michio Kaku, I've got if you want to read a really good article, go to Science Woke. I'll show that to you here. Science Woke. Go to, in fact, it's here. It's on one of my banners. One of the top ones here. There it is. Very good article I wrote about. Not because I wrote it, but it's a good article. Nevertheless, and that's about it says wanted science physics and it says the title is Science Evangelists, YouTube and the Woke Movement, and it talks about science evangelists, and I have a video about this, and here you go. Here's the current state of people like what I call science evangelists: Bill Nye, the Science Much, Michio Kaku, and Neil deGrasse Tyson. Look at this. I mean, this looks like a mystic. He looks religious, in my opinion. So, not good. I'm sorry. I don't have a lot of respect for them because they religiously follow it. If you make any mention that things could be actually wrong, then so Compton effect. Is the Compton effect fake? Can this prove the existence of a photon? Well, a photon in the sense of the I have a video called The Impossible Photon. Photons are impossible. The reason is because the concept of a photon is that one particle can carry the information of frequency, color, all that stuff. One photon can never do that. Frequency has to come with a frequency of multiple particles. And that's why the particle model that my father and I have, for instance, is a very good, I think, a much better model. But a photon itself is the idea that it carries frequency, and it is quite silly, in my opinion. So, but go to look up dissident science photon. Go to one of my latest, and it's called The Impossible Photon. So I do talk about that. But basically, it's because one particle cannot carry the information of light. It's got to be more than one particle. There's something, let's see. There's something very mysterious about mass. in my opinion. Yeah, absolutely. It's there and it's not there. It's really hard. And measuring mass is even more interesting. My father, if you want to subscribe to my father's channel, he talks about our particle model and those kinds of things. So basically, just go to HTTP. I'm trying to talk loud here because my daughter is singing because she's sings theater here. It's a particle. No, it'd be youtube.particle.guru. And my dad talks about that. The reason I'm telling you that to go there is he talks about this question. And it really comes down to what you consider to be mass and what it's made out of. If we measure mass in kilograms or we measure mass by weighing it in a gravitational field, that's one thing. But the gravitational field is only at the level we're at. Okay, just a minute. I'm going to mute my mic here. Oh, sorry about that, folks. No problem. And got her just to close our doors here. But anyways, if you go there, you can find out that actually, if you look at mass and you try to measure mass, you've got to have a model for everything to understand. But even measuring mass means mass, most most of our understanding is the resistance to movement. That's what a mass will be. It is, but if you look at a particle model or models that are of infinity, what you end up with is you look at something solid, like this little cylinder here, solid. Okay, oh, this is solid. No, it's not, because it's made of atoms. And if I go in here, I know that most of it's space. Most of this weight is the nucleus. So if I go in there, well, then if you believe in infinity, which I subscribe to infinity, what you have then is every subparticle in here is made of another particle, and those particles are made of another particle. And so that if you look at the proton, or what I call the nucleon, I'll just call it the nucleon. There's a nucleus to an atom. We're not exactly sure how that is, but the nucleon, it's going to be made of parts. It can't be infinitely dense, because if you don't have parts, it's going to be infinitely dense. You keep looking down and down and down, you never get to the mass. It's wispy. You never get there. And that's one of the conundrums. And you get to the point where you have to just say, I'm assuming there's mass. This is what it is, because otherwise you will drive yourself nuts, and it's easy to drive yourself nuts. Great riff, Dave. Oh, well, thank you so much about okay. Can you prove the existence? Oh, Compton effect. Going back to the Compton effect, you can read about the Compton effect on autodynamics.org. Let me put that up there. I think I've got that there. But this is neutrinos. But if you go to just autodynamics.org, Dr. Carazani talks about the Compton effect. Again, it only matters if you have a model for everything. The moment you don't have a model, you can sit there and talk about whether or not something is right or wrong. Can someone explain why quantum mechanics is wrong? I can. This is easy. Quantum mechanics comes from the double slit experiment. What's a double slit experiment? Well, let's look that up. And I can tell you why it doesn't work. All right, and there we go. Take a look at it. So here it is, the double slit experiment. This is where quantum mechanics comes from. And people can say, no, it's not. Well, it did. Quantum mechanics is where they said they're shooting one electron at a double slit, and they're getting an interference pattern. How could that be? Because an electron isn't a wave. Or then they shoot a photon. Well, light is a wave, so it's acting like a wave. But then if they put a detector right next to the double slit, then all of a sudden what looks like to be a wave then becomes a particle, and you just get two slits, as if you are shooting, particles through that. If you're shooting like paintballs through that, you're going to get two slits. Well, it turns out with all of those things and their philosophy behind it, I'm not going to get into that. The philosophy behind this, they start getting really crazy things like spooky action at a distance, that, one electron knows what the other one's doing. That observing an electron, if you observe it in one way, it's going to go through one slit. If you observe it in another way, it's going to go through another slit. It's all crazy. All those explanations come from the double slit experiment and the philosophical implications, which are absolutely crazy. And you get into things like history, eraser experiments, which are from the double slit experiment. Delayed choice quantum eraser experiment. I'm not kidding. This is real. The delayed choice quantum experiment is performed by in 1999 collaboration incorporates the considerations Wheeler's delayed choice experiment. Delayed choice experiment. Delayed choice quantum eraser experiment investigates a paradox. If a photon manifests itself as though it came through a single path in detector, then common sense says it must be enter the double slit device as a particle. If a photon manifests through it and comes through an indistinguishable path, two indistinguishable paths, then it must have entered a double slit device as a wave. So the problem is that they end up saying that what happens is this causes this problem of that basically their philosophy, and they go around the world talking about this, and basically they say, oh yeah, this is what these experiments, double slit experiments, show us. This is quantum mechanics. This is where quantum mechanics comes from. See, it says part of the series of quantum mechanics. Yes, it means things at a very small level, but that's another part of it. But basically, this whole thing is that this is what they say. They'll get on stage and talk to an audience, and they'll say these absurd things. Here's what they'll say: a photon's coming from a photon, one particle, is coming from a star 10 billion light years away. And as it's coming toward us, because that space, time, and all that general relativity is correct, it's going to go around. It's going to go around one sun on its way here. And if I look at it using binoculars, and you look at it using a telescope, it will go on. It could go on one side of that sun. If I look at it, it could go on the other side if you look at it. So how could the same photon go around that sun in two different places? It's impossible. So what they ended up saying, well, the only way to make an explanation for that is if all the observers in the universe have a collective consciousness, then it would go around specifically in one way. Yes, this is real. Yes, they really say these things. It's that bizarre. So how can someone explain why quantum mechanics is wrong? Well, the answer is that they have no physicality for what's going on. When they are shooting when they are shooting, I guess it's gone. Let me look it up. All right, when they are looking at, let's just look at this. Hold on. I'm going to open this image there we go. Getting better at this. Here we go. So this is what happens. They said that there are light waves that come through here, but what they ended up doing, that's not a good one. We want to shoot, there we go. This one, I'm going to look up in the corner here. They're shooting electrons. Hold on, I'm going to get to that one. I am going to open it up in a new tab, and then put that into our window here that we are looking at. There we go. So this is what's happening. There are particles that are being sent through here. The problem is they're saying that they're only shooting one electron or one photon. It turns out for instance, in our particle model, they're not. They're shooting, you can never shoot one thing. You can't. So they're shooting multiple particles because if it's coming out as a wave or whatever, they think they're shooting one electron, they're shooting more than one. They think they're shooting one photon, they're shooting more than one. And that already is starting a problem. When they put a detector next to it, it's got a magnetic field. In our model, you're shooting G1 particles. You're turning on a G1 particle generator that's a detector, which makes them in a circular manner. You're shooting something through that. Of course, it's going to affect the path of those things. So if you have a physical model, you're not going to need all this crazy interpretation. It's all going to be Newtonian physics. And our really good models, all of our good models outside the mainstream, they're all Newtonian. There's not, when they say it's quantum, all quantum means now today is it's small, or that it's got more than one state of, it's got a million states, a billion states, whatever. But quantum computing also. So it's been hijacked, but quantum mechanics comes from this experiment. It comes from the craziness of not knowing really what's going on. They think they're shooting one photon. They think they're shooting one electron. They think they're turning on a detector that doesn't interfere. It does interfere. This is all common sense. And so that's why it's a mess. You can just throw out quantum mechanics. Throw it out. Our particle model has a perfect explanation for this. And actually, another person who does have explanation for that is Eric, a reader. Let me go to that. You can go to his. If you go to quantum mechanics, if you go to our website, you go to problems in science, you click on quantum mechanics. Hey, there you go. I can't read, not sure if that's Chinese. Maybe, I think it is. You read here, quantum mechanics, you go down here, and you're going to get a quantum mechanics experiment has other explanation. This is by Eric Reeder. It's a little tough, but he wrote this article. You can get that information there. Okay. Right. Let's see. Here we go. Walter Russell said that light does not travel. Light is a rate of induction. Again, if a person on the street walks up to you and you say this, Johnny Doughboy, if you say this, here's what they're going to say. What is it? Quit telling me about how it travels, the rate of induction. What is it? Is it gummy bears? Is it ping pong balls? Is it waves in a water? Are we like living in water and it's just waves in that water? That's what people want to know. That's what I want to know. That's what we should know, in my opinion. Okay, can you explain moving conductor and magnetic problem without relativity? Oh, absolutely. Yes. And the problem is, again, is that because the moving conductor induction and magnetic problem is not understood and it's wrongly described. It's not only that it's needs to be explained, it's not being explained correctly. So in what's happening is the relativity comes in onto a situation with an explanation that's wrong of what's happening. So what's happening is something else. The explanation for what's happening and for what relativity is fixing it. It's like saying this, the moving conductor and magnetic problem. Well, if you have, it all has to do with moving charges, magnetic fields. Is a magnetic field moving charge? Here's the problem again. We don't have any model for any of that. So until we have a model, all this stuff is going to be all very confusing and all very wrong, because we don't, when we explain what we say is happening is different from what our modern models will tell you. So what I would say to you is the moving conductor and magnetic problem is not understood physically. It's being explained wrong. And once it's explained, there's no need for relativity ever, if anything. So that's my explanation for that. Of course, we proved that light is electromagnetic wave. An electromagnetic wave is something described by Maxwell's equations. Maxwell's equations have a lot of people who say there's lots of problems with them. Dr. Eberly Spencer, who has a PhD from MIT, will talk to you at length about that. And again, the problem is we have to have a model for light. Our model for light, even from photonics. I have a friend of mine who is a photonics expert. He is an Indian guy who works at the Department of Engineering, I believe, at the University of Connecticut, has been a photonics expert for 40 years, and he says we have no idea what the photon is. So if we're talking about light as electromagnetic wave, we don't have a model for it. So to say that's proven, I would say we don't know what light is at all. So a statement that light is an electromagnetic wave is a vacuous statement, because it's like saying, we know that this thing we have is light. That's what you're seeing here. That's what you're seeing me as. We know that exists. Yeah, it's there. But the idea of calling it electromagnetic wave is what we call it. It doesn't mean that's what it is. And in my opinion, it's not a wave the way we think it's a wave. Well, there are lattice models, ether models, and particle models. Solar wind consists primarily, wow, do we have a real picture of something? Hey, Ted, I saw you popping in and out. Be welcome to say hello. Solar wind consists primarily of charged hydrogen. Okay. When these particles slam against oxygen-laden rocks, silicates could in principle form water. There's no precipitation of star. Okay. It could. Here's my answer to you, Todd. It very well could be, and I would not dispute that because I don't know. I'd have to see, but the amount of water that's coming out of the bottom of the ocean, and the expansion tectonics, and the increase by the mass of the Earth that's coming from. We know that nucleons are coming from the sun. I would say that that is happening. It seems to come from the inside of the Earth. We even got in the last 2 years evidence that it's way, way down in the Earth. It's actually I think you can actually find. If I'm going to find that, and being produced. I absolutely believe that this year that they did talk that that there are hidden oceans, but that that water could be being produced inside the Earth. That's from mainstream science that came out. So very interesting, though. Todd, I will not argue against that. That sounds very plausible, but I would say it's sort of like the comet thing. It's not enough. It's not enough water to explain where it all came from. Explain the aurora without charged particles from the sun. Yeah, that's easy. That's very easy. You can explain charge without, you can explain what charge is. Something that we put as an attribute. A charge is an attribute, an arbitrary attribute we put on something that has a positive and negative. And for those of you who don't know, I always ask this question, where does it come from? Benjamin Franklin was the first person to put charge as positive and negative. And so just because we put a charge on one side and a charge on a negative on one and a positive on the other, and they come together, we have complete explanations of magnetic fields coming together. We know in our model with the electron and the proton, it's actually a gravitational field, one of super tiny particles, super fast particles, one level below, that keeps the nucleons together, that keeps the electron going around the positron, is what we would say, or we call a G1 particle going around a nucleon. So the whole thing is that you can, anything that's charged that is a force that ends up doing something at somewhere can be explained in a different way, of course. It's just a pushing force in the end. Dr. Michael Gregg is amazing. He's not a physicist. He is a doctor. That guy should win the Nobel Peace Prize in medicine, without a doubt. A lot of other people should, actually. What about can it prove the existence of photon? Oh, yeah, I did talk about that. Let's see. Oh, let's deceive the people like Saturn's. Oh, yeah. By the way, those people who talk about the flat Earth is a prank, a large prank by a number of people who put that out there and are making it go as far as possible, as long as possible. Yeah, there are probably some people who are pretending to believe it, but it's not. It's a big prank. I have inside knowledge about that. Let's see. Whole proverb about the wise man and the elephant. It's useful to see the different interpretations so we can get more complete picture. Yes, in fact, I have a video on that. You got to see that video. I made some really cool elephant things. Elephant, the latest. Here, we'll show them. You'll see the elephant down here. There it is. Four forces of nature. And this is a really good. If you have not read this or seen this, the four forces of discernment perspective, you'll enjoy that quite a lot. But here's I love this. this is the universe, and you have the people over here saying, oh, it's gravity, oh, this is weak force, oh, electromagnetism. Well, the universe, there's no such things, and you have to come up with, some explanation for it. So I did talk about that. If you want to take a look at that, that's pretty cool. All right. I see a lot of back and forth, but let's see. We're all at all varying stages, and the host is a mathematician. I study chem. Yep, that's true. Neil Adams, if you don't know, again, Neil Adams did those great animations on expanding Earth, and he is also a cartoonist. He's known for Batman. I think he's pretty wealthy now for that. But he said something very profound. He says, we all just own part of the truth. Very good. Skeptics and critical thinkers. Absolutely, that's what we are. That's why you want to go to our website, Science Woke, right there. And at the top, it says, you can't see it, it's pretty small, online science magazine for critical thinkers. That's what we are. Again, if you want to come and join me and have a conversation, what time is it? Oh my goodness, I started at 9. Is it really 2.5 hours? Oh my gosh, it is. That's absurd. It seems like I was going to look up and say, did I get to 1.5 hours? Holy moly. You guys have been really great. I know people are in and out for sure, but this is recorded live, so you can actually go back and see it. Wow. That's freaky. Yeah, I guess we're not going to talk. I guess we're going to come to an end here pretty soon. Let me go all the way to the bottom. Todd Checkner. CME are known to cause oxygen to release from, yeah. Oh, you must be a geologist. Todd, I would absolutely. This is the most important geology book ever written. Not a good one, ever written. Definitely worth taking a look at. I think you enjoy that. Justin, too. Todd's statement makes sense to me. Yeah. So in the paper I posted earlier, show you the addition of cosmic rays, and it can count for anomalies in waters or medium. Yeah, absolutely. I'm all. I think those kinds of things are super interesting. I always believe in real stuff. You got real stuff, real pointing to all this stuff. Chemistry. But I think that should be it, unless anybody else has something else they want to talk about. Don't skip all the questions. Laugh. I think you got them all, I think. A wave is not a thing. Wave-particle duality. Wave-particle duality. I think my dad had a solution in June of 2015. In my opinion, the best solution for a wave I've seen to date. I'll show you a picture of it. It's not the best. It's not the real closest picture to reality, but it's a. There it is. See if I can put this in a new tab and show you. There you go. The wave-particle duality described. So what you see here is one solution to the wave-particle duality my father came up with. So this is an idealized way, so you can see it very easily. All of these dots are particles. Okay, they wouldn't be photons, because photons, again, have a historical implication of carrying frequencies. So these are just regular photons. They could be rocks. They could be ping pong balls. They could be basketballs. They could be meteors. They could be suns. Whatever. They will be traveling, and they will all be traveling together at the same speed. I've got a better picture here. I'll show you. But this is a solution to the wave-particle duality. Here we go. This is a good one. Two good pictures. It's in our book. Why don't you get our book? Oh, book's not here yet. Okay. Gotta see what I'm seeing. See all those particles? They're coming in waves, right? Just like those bombers you see coming in waves. You see the little arrows on those particles? They're all traveling at the speed of C together, like bombers. And what do you get? Brum, 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 brum. What I did just right there was a frequency. And that is not through a medium. That is not ether. My father came up with that model. And when he did, I went jumping through the roof. I mean, I went nuts. My dad didn't know why until I told him. I said, you gave a solution to the wave particle duality. He didn't believe me. 2 weeks later, he comes back to me, knocks on my door, he goes, Dave, I think I gave a solution to the wave particle. You notice how I say he didn't solve it? He gave a solution to it. The first one I've seen. So the wave particle duality. A wave is not a thing. A wave is something that does. A wave is of water. Yeah, somewhat. A wave, even the way I describe it with our particle model. Do I have a newer book? I've got a really great. I'm looking. Oh, so many good books around here. So many. Do I have the latest particle model book? No, I do somewhere and I'm not finding it. Sorry about that. But in there, the way I look at it is this. When somebody asks me what our model says about light and gravity is this. If you take and you push on your shoulder, just hold on to it. Push. Don't move it. That force, that's gravity. It's a constant force. Now you do this. That's light. Same particle. The only difference is that they come in waves. Gravity comes in random. So what does that mean to the electric universe? Our particle model, this is interesting. Our particle model says that electrical forces and magnetic forces are simply particles moving in the same direction. It's the same, more or less the same speed. Not true, but close to the same speed. And that gravity are particles moving in random directions. That's it. The entire universe can be made from that. So that's our particle model. But that's interesting. Again, I'm only telling you because that's what I know. Maxwell experiments even doesn't prove the speed of light's constant relativity. Yeah, he proved a constant in a definite location. Yeah, that's true. Maxwell is not a physical model. It's mathematical equations. What about explaining moving conductor? Okay, I did talk about that. Quantum is messed up because Mother Nature doesn't work with a calculator. No, Mother Nature works, and it's a physical thing happening. There is no such thing as spooky action at a distance, or infinitely fast or instantaneous anything. There is no instantaneous anything. So it's more that quantum is messed up because we have no idea what Mother Nature is really doing in the physical world. Gosh, you guys got to stop. I guess if I just keep people funneling in. Todd's statement makes sense to me. Okay, theoretical. Okay, now they're just talking about. That's okay, cool. You can read that if you'd like, folks. Interesting. All right, don't forget to explain antimatter. Antimatter is the same thing as charge. It's something that push and pull. That's even a better one. Push and pull don't exist in the universe. There's only push. But the pull is convenient because it's like pulling is actually pushing, like here it is. This is sitting here, right? I'm going to pull it toward me. Look, on your side that you're seeing in the camera, to me, I'm pulling it toward me. But to you, I'm pushing it. That's weird, isn't it? It's the same thing with matter and antimatter. It's just the way we explain things. It's just like, okay, we have a system of stability, and that, it's sort of like plus and minus, and that if this comes in contact with that, it sort of annihilates something. And we get that, I think, mostly from chemistry than anything. And so it's just a semantics. It's just meaning. It doesn't have any necessarily meaning in the real world unless we come up with something that says, if you put these two things together, this is what happens. But most of the time that's chemical, and we can explain that in our model, for instance, in a very clear and straightforward way. It's just movement of particles at all times, even. But again, it's all. How about limits? Are you familiar with Sir Roger Penrose? Something that's a math in infinite boundary is cold and hot equivalent, which account for infinite big bangs and expansion. I can get into that, but I think I'm going to get into that another day. The whole thing about the universe. The universe, in my opinion, most of us outside the mainstream, the universe is infinitely large. If you go in that direction, you'll always go in that direction and never stop. You'll probably find stuff the entire way, all the way forever. The universe has the Big Bang. If you don't believe, if you want a simple explanation that you can explain and even understand why the Big Bang is not a good idea, is why do we teach everybody in school the life cycle of planets and stars? If the Big Bang is a one direction, why is there the life cycle of stars and even galaxies and planets? That's a cyclical thing, not an explosion thing. So there you go. So the whole idea of a finite or infinite boundary, no, there's an infinite boundary. There's no boundary. There's no boundary. To say there's an infinite boundary is kind of silly, in my opinion. Could humans create an independent atmosphere on Earth in a vacuum for experimental purpose to tinker with? I'm not sure. Okay, maybe there's zero gravity vacuum. Okay, they're talking about stuff. Okay, clockwise and counterclockwise. All right, folks. I think I'm going to wrap it up here. I appreciate it. I've seen we've gone from anywhere from 8 or 9 at the lowest all the way to my goodness, almost up to 20. So people are coming. I appreciate it. I am trying to get that video out, folks. I've just been super busy, and those videos take forever to make, and especially this one because it's so darn long. I just got way long. I've written it, and the video itself is over 22 minutes long, and that's a lot of editing, a lot of graphics and stuff. But I'm hoping that you guys are getting some good information out of this. I do know people do watch these later on as well. I appreciate everybody's subscriptions. I want to invite you to come on. The good thing about what this whole technology is, we go live to Facebook or YouTube, and you guys can come in. Just a reminder. For those just the next time around, if you are so inclined. I do not make fun of you. The only time I cut you off is if you can't come in here and are just trolling or bashing, or you're not interested. I will take all questions seriously. I don't really talk too much about UFOs or conspiracy theories much. I believe that there are kinds of wild things out there that are not good in mankind. I do know there are people who've worked in what they call the free energy area that have mysteriously disappeared, those kinds of things. I don't talk about that too much because I've decided myself not to talk about politics, not to talk about UFOs or conspiracies, because we got to just learn what light is, folks. That's why my dad and I are writing a book. So anyways, I appreciate everybody's continuing to subscribe, let people know about the channel. And like I said, next time I'm on, think about coming live to Dissident.science. All you need are some earbuds, your telephone. That's all you need. And you can come on and we can have a discussion back and forth. And nothing, I can work with anybody at any level. I believe that if you're coming and want to discuss, that be civil and all that stuff. All right, folks, thanks so much. I appreciate it. And, I am your science therapist, and I hope I'm bringing you to the promised land of becoming a critical thinker. Ciao for now.